Hi guys, a very good day to all of you, and welcome back to Budget Power Electrical Solutions. Have you ever wondered why, when we explain AC power, we always use a power triangle? Why a triangle? Why can't we use a square, or even a pentagon? Is the power triangle simply a convenient shape for calculations? Or is there a real electrical reason behind it? Today, we're going to uncover the real reason behind the power triangle. And by the end of this episode, you'll understand why it has to be a triangle. So let's get started. Now look at this carefully. In one AC system, we have voltage, current, frequency, real power, reactive power, apparent power, power factor, and phase angle. They all belong to the same electrical system. But when we explain power, only certain quantities suddenly form a triangle. Why those quantities? Why not a square? Why not a pentagon? The shape should come from the electricity, not from our imagination. So let's find out why the power triangle really exists. Now let's move to a real AC system. Here we have a three-phase supply, a power analyzer, and an induction motor. Suppose the analyzer shows 400 volts, 14.4 amps, 50 hertz, 8 kilowatts, 6 kVAR, 10 kVA, and a power factor of 0.8. We'll use these measured values to see how the quantities are related and find out whether the electrical relationship naturally creates a triangle or some other shape. Alright guys, this is the point where I really want you to concentrate, because this is where the whole idea starts to make sense. We have 8 kilowatts of real power, 6 kVAR of reactive power, but only 10 kVA of apparent power. So why does an 8 plus 6 simply give us 14? That tells us these two power components are not combining in the same direction. And this is exactly where the geometry begins to reveal itself. Before we move forward, if you enjoy practical electrical explanations like this, please subscribe to Budget Power Electrical Solutions and stay connected for more technical videos. Guys, now we are at the key point. Real power and reactive power are not simply added like ordinary numbers. We represent real power, P, along the horizontal direction, and reactive power, Q, along the vertical direction. Why? Because in AC power, these two components are in quadrature, effectively 90 degrees apart. So now we have 8 kilowatts horizontally and 6 kVAR vertically. Once these two components are at right angles, we can no longer just say 8 plus 6. Now we have to ask a different question. What is the resultant of these two perpendicular power components? And that resultant is where apparent power begins to appear. That last sentence is a perfect transition into the next subslide, where we reveal S equals kVA as the diagonal. Now we know that real power, P, and reactive power, Q, are 90 degrees apart. In our example, real power is 8 kilowatts horizontally, and reactive power is 6 kVAR vertically. When we connect these two components, the diagonal represents apparent power, S, measured in kVA. Because the two components are perpendicular, we use the Pythagorean relationship. 8 squared plus 6 squared equals 100, and the square root of 100 is 10. So the apparent power is 10 kVA. And this is the key point. We did not choose the triangle first. The electrical relationship itself created the triangle. Now we can answer the original question. Why not a square or a pentagon? Now we have reached the answer we were looking for. We started with real measured electrical quantities. Real power was placed on one axis, reactive power on the perpendicular axis, and their resultant became apparent power. Without choosing any shape in advance, the relationship naturally formed a right-angle triangle. So now, let's return to our original question. Why not a square? Why not a pentagon? A square would need another independent component to complete its geometry. A pentagon would need even more. But in this basic AC power relationship, we have two perpendicular power components, real power and reactive power, and one resultant, apparent power. So the geometry naturally gives us three sides. That is why it becomes a power triangle, not a square or a pentagon. So now the picture is clear. Real power and reactive power are perpendicular components, and apparent power is their resultant. That electrical relationship naturally creates a right-angle triangle. So the power triangle is not a chosen shape. The relationship itself creates it. Thank you for watching Budget Power Electrical Solutions. If you enjoy practical electrical lessons like this, please subscribe, leave a comment below, and I'll see you in the next episode.